Welcome to the channel, where today we're unlocking the power of data. We often hear that data is the new oil, but raw data alone is just a collection of numbers. The real value emerges when we transform that data into compelling stories, and the best way to do that is through effective data visualization. In this practical guide, we'll explore essential graphs and charts like histograms, box plots, and bar charts, teaching you how to create and interpret them to improve your understanding and communication of statistical information. Why should we bother with data visualization? Imagine trying to understand a complex spreadsheet with thousands of rows and columns. It's overwhelming, right? Visualizations cut through that noise, making complex datasets accessible and understandable. They help us spot trends, identify outliers, and communicate insights far more effectively than any table of numbers ever could. It's about transforming raw information into actionable knowledge. Let's start with one of the most fundamental charts, the bar chart. Bar charts are incredibly useful for comparing different categories. Each bar represents a category, and its length or height corresponds to the value it represents, such as counts, sums, or averages. For instance, you could use a bar chart to compare sales figures across different product lines, website traffic from various sources, or the number of students in different academic majors. Creating an effective bar chart involves a few best practices. Always ensure your axes are clearly labeled. The categories should be distinct, and often, sorting the bars in ascending or descending order of value can make comparisons much easier. Avoid using 3D effects, as they can distort the perception of bar lengths and make the chart harder to read accurately. Simplicity and clarity are key. Next, we move to histograms. While bar charts compare categories, histograms are designed to show the distribution of numerical data. Imagine you're looking at the ages of all your customers. Instead of comparing each individual age, a histogram groups ages into bins or ranges and then shows you how many customers fall into each age range. This reveals the shape, spread, and central tendency of your data. Interpreting a histogram means looking at its overall shape. Is it symmetrical, skewed to the left, or skewed to the right? Does it have one peak or multiple peaks? These shapes tell us a lot about the underlying data. For example, a left-skewed histogram might indicate that most of your data points are on the higher end of the scale. Also, pay attention to outliers, which appear as small bars far from the main distribution. The number of bins chosen can influence the appearance, so it's often good to experiment slightly. It's crucial to distinguish between bar charts and histograms. Remember, bar charts are for categorical data, distinct, separate groups. Histograms are for continuous numerical data, showing how frequently values fall into specific ranges. While they might look similar, their purpose and the type of data they represent are fundamentally different. Using the wrong one can lead to misinterpretation. Now let's introduce box plots, also known as Box-and-Whisker Plots. These are powerful tools for visualizing the distribution of numerical data, especially when comparing distributions across multiple groups. A box plot efficiently summarizes the 5-number summary, the minimum, first quartile, median, third quartile, and maximum, along with highlighting potential outliers. Dissecting a box plot, the central line inside the box represents the median, which is the middle value of your data. The box itself spans from the first quartile, which is the 25th percentile, to the third quartile, the 75th percentile. This box therefore contains the middle 50% of your data. The whiskers extend from the box to the minimum and maximum values within a certain range, often 1.5 times the interquartile range. Points beyond the whiskers are typically considered outliers. Box plots shine when you need to compare the distributions of several different groups. For example, you could use box plots to compare the test scores of students from different schools, the salaries across various departments, or the response times of different servers. By placing them side by side, you can quickly see differences in median, spread, and the presence of outliers between groups. Choosing the right chart depends entirely on your data and the story you want to tell. For comparing discrete categories, a bar chart is often your best bet. If you want to understand the shape and spread of a single numerical dataset, a histogram is ideal. and for comparing the distributions of numerical data across multiple groups, box plots provide a concise summary. Always consider your audience and your message. While data visualization is powerful, it's also easy to fall into common pitfalls. Misleading visuals, such as truncated y-axes or disproportionate scales, can distort reality. Cherry-picking data to support a predetermined narrative is another ethical concern. Always strive for accuracy, transparency, and integrity in your visualizations to build trust with your audience. We've covered some essential graphs today, but the world of data visualization is vast. As you grow more comfortable, explore other types like scatter plots for showing relationships between two numerical variables, line charts for tracking trends over time, or pie charts for showing parts of a whole. Each chart type has its strengths and ideal applications. So, there you have it, a practical guide to telling stories with data using bar charts, histograms, and box plots. By mastering these fundamental tools, you'll be well equipped to transform raw numbers into compelling narratives, uncovering insights and communicating them effectively. Start practicing with your own data, and remember, every dataset has a story waiting to be told. If you found this guide helpful, please like this video and subscribe for more content on data analysis and visualization.